In this video, we're going to look at the number e and the derivative of the natural exponential function. So there is a special number b, for the base b, for which the derivative of b to the x actually equals itself b to the x. This is what makes this function so special. The derivative equals the function. And the special number for which this works is e, which is sometimes called Euler's number. Now e, you may have heard of, it's an irrational number. And we're going to look at it on the calculator here to get a little decimal approximation to e. So to do this, we're going to turn it on, and then we're going to find the e button. Mine is right here above ln. So I'm going to hit second ln and enter e to the power of 1 to get a nice, good decimal approximation for e. Now it appears right here that it repeats 2.718281828, but it actually does not. After that, the decimals vary. I don't have them memorized or anything. So 2.718281828, and then so on forever and ever. It goes on out. Okay, it's irrational like pi, so the decimals never repeat. It's just this cool special number. So the derivative of e to the x is itself e to the x. And this is an exponential function that is used often in applications. It arises in just the natural world and biology and so on quite often. So here's a visualization of what I'm saying. Here's the graph of f of x equals e to the x here in pink. Okay, you can see that e is about the number 2.718. So 2.718 to the 0 power is 1. 2.718 to the first power is itself 2.718. You can see that y value right there. 2.718, 28, and so on squared is about 7.39. The slope of the tangent line equals the y value, which is pretty cool. The slope of the tangent line right there at 0, 1 is actually 1, in which you can visually see, you just eyeball it, that does look like a slope of about 1. Right here, the slope of that tangent line at 1, 2.72 is about 2.72. And at 2, 7.39, the slope of the tangent line is very steep. It's about 7.39. Very nice. So the derivative of, for example, 4 times e to the x, we would pull that constant 4 out front to have 4 times the derivative of e to the x. But the derivative of e to the x is itself, so we actually just get 4 times e to the x. And here's another graph of y equals e to the x. And keep in mind, this is the graph of y equals 2.718 to the power of x. So its graph is between that of y equals 3 to the x and y equals 2 to the x. So you can get an eyeball here of how it compares to those other graphs.